All right, it's time to continue with our identities. Again, here are the identities that you must know. So I'm putting them out there again. Hopefully you have practiced them. You are really getting to learn those. So we are going to be verifying today, and that's kind of like a proof you did in geometry, where you're verifying that one side is the same thing as the other side. So here we go. Verifying trigonometric identities has no well-defined set of rules to follow, and the process is best learned by practice. So it is crucial that you practice. That's how you're going to get the hang of doing it. Here are some general guidelines for you, though. Number one, work with one side of the equation at a time. It is often better to work with the more complicated side. So when you start an equation, so for example, this first one, we would want to pick the more complicated side. So this left-hand side, and that means we are not touching the right-hand side. The right-hand side will continue as it goes down. The left-hand side is the one that we're going to touch. Number two, look for opportunities to factor an expression or add fractions. So anytime that you can get a common denominator and add the two fractions together, or if there's something that you can factor, you might want to try that because that's going to help you simplify. Number three, look for opportunities to use the fundamental identities. So be always watching for those identities to see if you can convert something from something more difficult to something easier to work with. Number four, if the above steps don't help, try to convert everything to sine and cosine. Those are usually the easiest ones to work with, so you might want to convert to those. Number five, always try something. Even paths that lead to dead ends provide insight. So always, when you get to the problem, start working it. If that means that in the middle, you're going to have to erase and start over again, that's okay, because you've learned something from it as you've gone through it to make sure that you're getting it. So we're going to start with some examples here of how we would approach this. Again, I'm going to only work on one side. You can't touch the other. So pick one side to work with, and it doesn't matter which side you pick, in order to get it to verify. And so here on this one, I'm going to pick the left-hand side because that's the more complicated one. So if I can simplify it down, it should be equal to 1 because that's what it told us here. So they're never going to give you something that's not equal to each other. That's what the whole verification process is. You're proving that this left-hand side is the same as the right-hand side. All right, so when I see this cotangent squared of x times secant squared of x minus 1 is equal to 1, I see this right here as one of my identities. Secant squared of x minus 1 is the same thing as tangent squared of x. So that's what I'm going to start with first. I convert this to a tangent squared of x. Now, as I'm looking at this, I remember that cotangent squared of x is one of my reciprocal identities. So I can change that to be 1 over the tangent squared of x times tangent squared of x is equal to 1. Well, all whole numbers are over 1. So now I've got something in the numerator and the denominator that can cancel. And so that would just give me 1 over 1 is equal to 1. I have proven this. So this is what you're doing when you're verifying. You are proving that one side, notice that this right-hand side stayed as 1 every single time until the left-hand side turned into 1. All right, so we're going to try another one here. Number 2 it says secant squared of theta minus 1 over secant of theta is equal to sine squared of theta. Again, I'm going to start with this left-hand side. I think that's the more complicated side, so I'm going to change that one. And actually, again, I recognize that secant squared of theta minus 1 is the same thing as tangent squared. I do not touch the right-hand side, so it stays the same. Now, at this point, I'm going to go ahead and convert it. The tangent squared of theta with my quotient identity is sine squared of theta over cosine squared of theta. And secant squared of theta is one of my reciprocal ones. So I'm going to go ahead and convert that to 1 over the cosine squared of theta. The right-hand side does not change. Now, anytime that we have a fraction over a fraction, we do that keep, change, flip. So that's what we would want to do here. So I'm going to keep my sine squared of theta over cosine squared of theta. I'm going to change that to multiplication, and I'm going to flip this bottom one. So it becomes cosine squared of theta over 1. The right-hand side does not change. Again, I've ended up with something that's the same in both the numerator and the denominator, so that cancels. and we get sine squared of theta is equal to sine squared of theta. So we have proven that those two sides are the same. That's what the verification is. All right, number 3 here. The left-hand side is definitely the more complicated one, so that's the one I'm going to start with. I recognize that in the numerator, sine squared of theta plus cosine of squared of theta is one of the identities I'm supposed to know. I told you we'd use that one quite a bit. So sine squared of theta plus cosine squared of theta is 1. And secant squared of theta is 1 over the cosine. Again, we have something in the numerator and denominator, so that cancels and we get 1 over 1 is 1. And so that one all canceled out. So we use this top part here. That's 1. We change the secant squared of theta to be 1 over cosine squared of theta. Now in these equations, notice that they've already given you what it is. They've told you all of this is 1. So when we're grading this, we're not grading to see what it comes out to be because we already know it's 1 right here. We are grading the process. So you've got to make sure you're showing those steps because we're awarding points to each one of those steps as we go down. That's the verification part. All right, we are going to try some that are a little bit harder or a little bit more involved. So here comes this part. In this case, we've got 2 different fractions. So this is one of the ones that we would want to look at as to combine to make one fraction. In order to do that, we have to get a common denominator. So I'm going to start with that. My common denominator would have to be 1 minus sine and 1 plus sine. I'm just going to put a quotation here for the right-hand side because we know we're not going to touch it anyway. To get from this first denominator to this new one, I multiplied times this 1 plus sine. So that's what I'm going to multiply the top. Now, since I'm multiplying it times 1, that's just itself. Now, to get this second denominator to this new denominator here, we multiplied times this 1 minus sine. So I multiply the top times it. Since I'm multiplying it times 1, it's just itself. Now you should recognize these two right here are the difference of 2 squares from that factoring part. So if I multiplied it out, because they're both squares with different signs, then it is going to be 1 minus sine squared. Because our middle terms are going to cancel. So I'm going to rewrite what I have here by multiplying that. And now I can write my 2 secant squared. Now that I have a common denominator, I can put these two together. And so I'm going to keep my denominator of 1 minus sine squared. For the top here, 1 plus 1 gives me 2. Sine plus a negative sign gives me 0. So these two are going to cancel out when I add them together. I have simplified quite a bit here, but I'm not quite done yet because I am not at what the right-hand side is too. So I need to recognize that 1 minus the sine squared is cosine squared. Sorry, I don't like the way that looks. Cosine. At this point, you should recognize you're getting pretty close. So we have the 2 on both of these. The last thing I need is cosine squared, and I know that cosine is the reciprocal of secant. So this is 2 secant squared. And so now they are both the same. I have verified. Again, the points are awarded for these steps in showing the verification, proving that they are equal to each other. All right, for number 5, it's got tangent squared of x plus 1 times the cosine squared of x minus 1 is equal to negative tangent squared of x. So we want to go ahead and prove that both of those sides are the same. And so in order to do that, tangent squared of x plus 1, I should recognize as secant squared of x. And then this one's kind of tricky because we know that sine squared of x is equal to 1 minus the cosine squared of x. That's not quite the same as this right here because the cosine here is positive and the 1 is negative. And here the positive 1 and a negative cosine. So the signs are switched. That means that negative sine squared of x would be equal to -1 plus cosine squared of x, which is what we have there. I told you you're going to have to get comfortable with manipulating these. So this would be a negative sine squared of x. Now we're still not quite to the right-hand side, so we have to work a little bit more. Secant squared of x is the reciprocal, so we know that is 1 over cosine squared of x, and we are multiplying that times negative sine squared of x. Remember, any whole numbers over 1. And so we multiply those across and we get negative sine squared of x over cosine squared of x. And that's our quotient identity. We know that sine squared of x over cosine is tangent. So we have verified those are both the same. Again, there's no right and wrong way. You've got to just get started. You've got to practice. You've got to recognize those identities. And lots of times you're going to make a mistake and you're going to have to start over again. All right, on this one here, I'm going to go ahead and start on this side, and I'm going to go ahead and use my quotient properties. So tangent of x was sine of x over cosine x. Cotangent of x is cosine x over sine of x. Anytime that we have a fraction, one of those guidelines that we said was try and get those together. So we want to add these to make it one fraction. In order to do that, you have to have a common denominator. So I'm going to get a common denominator between these two, which would be cosine x, sine x. We never change the other side, so I'm just going to put that there. To get from this first denominator to this new one, I multiply times sine x. So I'm going to do the same thing to the top, and I get sine squared of x. For the second one, I multiply times cosine of x, so I get cosine squared of x. Now I'm ready to add the two together because they have a common denominator. So I keep my denominator of cosine x, sine x, and I add my numerators. So that would be sine squared of x plus cosine squared of x. The right-hand side is staying the same. As it goes down, you never change the other side. This is an identity you should recognize. Sine squared of x plus cosine squared of x is 1. So we get 1 over the cosine x, sine x. And then you should recognize these reciprocal functions. 1 over the cosine is secant, 1 over the sine is cosecant. So we have verified that side. All right, one last one before you guys start practicing. Again, make sure that you practice this. The more you practice, the better you get at it. For our last one here, again, I'm going to start on this left-hand side. I'm going to use my reciprocals to change that to 1 over the sine of x minus the sine of x is equal to the cosine of x times the cotangent of x. There are two fractions here. This one is over 1 since it's a whole number. I'm going to have to put those two together to make them one fraction, so I have to get a common denominator. I don't need to change this one at all. It already has a denominator that I can make this one have. In order to get from 1 to sine of x, I multiply times sine of x, so I'm going to multiply the numerator to sine x as well, and I get sine squared. I combine my two fractions now, and so I'm going to keep the denominator, and I'm going to subtract the numerator, so I get 1 minus the sine squared of x. When you get to this point, you should recognize this identity. That's the one that I told you we're going to use most often. We used it over here, sine squared plus cosine squared of x as 1. This one is just manipulated. 1 minus sine squared of x is cosine squared of x. I'm not quite to this right-hand side, but I see that I need a cosine by itself. And so I'm going to separate that top part to be cosine of x times cosine of x. And so this part right here is cotangent. So we get cosine of x times cotangent of x is equal to the cosine of x times the cotangent. And we have verified that those are equal to each other. That's the goal here, is to verify that the left-hand side is equal to the right-hand side, and you are proving it by using those identities. Now it's time for you to practice.